Just trying to find a decent problem that won't take me too long. This is number 11. Might be your homework too, I don't remember. I don't care. It's a 1200 centimeters squared of material, maybe cardboard or whatever, right? So I have 1200 centimeters squared of material to make a box. And the box has an open top and a square base, okay? So right away, I can draw my picture instantly. So I know the base is a square, right? So that's going to have x by x sides. And the height of the box is unknown, right? But what's important is that I know that that box does not have, right? So that's solid. All my sides are solid, etc., right? But the box top itself is open, right? And so what height are the sides is unknown, but obviously it's a y, right? So I want to find the largest possible volume. I want to maximize the volume, right? So let's max the volume. And that's, of course, x squared y, right? That's pretty obvious, right? Length, width, depth, right? So what we kind of have to figure out here is our equation, right? But clearly we're talking about surface area, right? So that's our surface area. And so it's just a bunch of areas of rectangles added up, right? So hopefully you see there's one square piece and what is it? 1, 2, 3, 4 rectangles, right? So I know my 1200 centimeters squared is going to be x squared, 1x squared, 1 square, plus 4xy, right? Because there's 4 of those rectangle panels that build the side. So there it is. I have everything I need, right? I have everything I need here now. I have an equation that I figured out from my picture. I know what I'm trying to maximize, right? Trying to maximize the volume. So that there's my expression. I need to create a function of x. And so what am I going to do? I'm going to solve for y in the first equation, right? So in the first equation, what do I get? I get 4xy equals 1200 minus x squared, or y equals 1200 minus x squared over 4x. Is everybody with me? Nice. Hey, Markins, I didn't understand that email.
Oh yeah, I needed like the passcode for the past test because I want just to look at it to work on it.
You mean the actual test?
Yeah, no. Like the past test, chapter 2. Chapter 2 test, like
Chapter 2 test, yeah. Didn't I post the solutions with the test in it?
Yes, but like when I tried to open it, I couldn't open it like yesterday.
No, a PDF, the solution.
Yeah, but I couldn't open it. Nah, I couldn't open it yesterday when I was trying to open it.
Okay, were you opening it from an email or opening it from Blackboard?
Oh, no, from the email.
No, you can't. You got to go into Blackboard and open it.
Okay.
Yep. All right. So
Thank you.
Yes, you got it. So I now want to take this value of y and put it in my function of x, right? So I create a function of x. So f of x is x squared y, which is x squared times 1200 minus x squared over 4x. So then I want to maximize this. Pretty easy. So clearly it looks like I got an x will cancel, right? So I have a x times 1200 minus x squared over 4, right? And I certainly can just distribute this. It'll make it a very, very simple if I distribute it, right? So I get 1200 over 4 times x minus x cubed over 4. Of course, I can simplify that, right? 300x minus x cubed over 4. So there's my function. I didn't have to do all of that. I could have certainly used a different process to do my derivative, but why make myself work too much, trying to make things simple. So derivative, yes, everybody following? Everyone comfortable? Yep, good. So f prime of x is 300 minus 3x
We lose
squared
the x squared because the geometry of the...
Correct, yeah. So volume is length by width by depth, right? Or whatever, height. Area of the base times the height for volume, right? Nice. And you see I'm going to get a negative out of this. I'm going to get two solutions, but obviously I can't have a negative side of a box. So we're only going to care about our positive solution for this critical value here. And so f prime of x equals 0.
Yes, can you go over a little bit, sir, please?
Yeah, scroll up.
Yeah, but after you minimize f of x equal x squared, but what if you put x squared over here? After you put equal.
I canceled an x, right?
Oh, okay, I see it.
Yep. So f prime of x is equal to 0 tells me that x 3/4 x squared equals 300, or 3x squared equals 1200, or x squared equals 400, right? And x equals plus or minus square root of 400, which is what, 20? And we only want the positive. And of course it's centimeters. What's the matter, Jess?
Well, of course, my computer nuked me off the face of the earth when I ask a question. Not having the greatest morning. What was the...
Here we are. Here's the whole problem, and it's recording. So I'm getting a surface. This is number 11 and 4.6. I'm getting a surface area of 1,200 centimeters squared to make a box. So I've got a bunch of cardboard and making a box. There's an open top and a square base. I draw my picture, and I want to maximize the volume. So this is from my surface area, and this is what I want to maximize the volume. So don't bother writing, trying to catch up. Just take a look at what we did. We took our surface area, solved for y, plugged it into the expression in x and y to get a function of x. And I simplified the function as much as I could. There's my function. And then found the critical value. Now, I found that x is 20 centimeters, right? Because I know we're talking about centimeters squared for surface area. So anytime I'm talking about one dimension, it's centimeters. I need to figure out y. I need to figure out the area. And I need to figure out that it's maximized. So I want to work on the maximized piece first. What am I going to do? I'm going to take my first derivative and get a second derivative, right? So you can see at the top of my screen is my derivative. So f double prime is 0 minus 6x over 4. So negative 3/2 x. And if you see that if I put in my value of 20 to the second derivative, I get a negative, right? So negative 30, right? But who cares? I only care about the negative piece of it. So negative people frown, right? Negative people frown. So I'm looking at this concave down piece, so I know I got to have a max. All right, so I've got a couple more things to find and then a write-up, right? So I know x is 20, I need to find y. So I had an original expression in x and y with an equal sign from my surface area, right? So I can put my x in there and solve for y. So I'll do that real quick. 1200 equals 400 plus 80y. Right, I put in the x is 20, so x squared is 400. 4 times 20 is 80. And so it looks like I get 800 equals 80y, or y equals 10. Not a very big box. So we know x is 20 centimeters, y is 10 centimeters. We have 1200 centimeters squared of surface material. F double prime of 20 is negative, and the only thing left to find is the area, but the area is x times y, so 4,000 centimeters squared. Is that right? 20 times 20 is 400, times another 10 is 4,000. So with this, we can write our conclusion.
4,000 is good.
Yep. So conclusion, right? The volume of a box with a square base and open top.
Why not volume be cubed instead of squared?
Thank you. You're correct. Maybe that one was on purpose. It's not our area. I wrote area. It's volume. Thank you. Area is squared. The volume of a box with a square base and open top is maximized with sides of 20 centimeters, 20 centimeters, and 10 centimeters. Something like that. No. You know, you want to mention the pieces that you found along the way. It's enough for me to have up here verified I got a maximum. That's fine with me. Just show me somewhere on the page you're using the second derivative to find it, to show that it's maximized or minimized. Cool. Nice. So this is we're going to turn it up a notch. I mean, the problem we started Monday was tough. But make sure you do it over, right? You saw my mistake. I accidentally had written cubed instead of squared for the area of the triangle.
Vincent,
Yes.
For like the test, are you gonna tell us which items that are required for the conclusion?
No, you'll know. It's everything. Everything that's involved, you need to know. So our next problem that we do, I'm going to ask for a min distance. I'm going to ask for a point. I'm going to ask to show, so you need to show the distance. You need to find the point. You need to find the y, right? So you need to find the x value. You need to find the y value. You need to show that it's the min distance using the second derivative. So just everything that's mentioned you need to find, right? Put a quantifier on it, put a number on it, okay? So here's my favorite problem. It's on every chapter 4 test I've ever given. I want to find a min distance. So we'll do this one in detail today. We'll do another one on Friday, and then we'll start chapter 5 on Friday.
This is
Still 4.6.
6, okay.
Still optimization, right? So I could see myself giving you a simple geometry problem. I don't think the bent iron into a square into an equilateral triangle is simple, but the one I just did certainly is simple, right? And then a min distance problem. I can see myself giving you 2 of these on this test coming up. And then, so I'm trying to get to 7 problems, right? Min, max, absolute min, and absolute max function from 4.2. And then I've got 2 questions on first derivative test and 2 questions on second derivative test from 4.3, and that's it. So there's my 7 problems. And I'll write that down when we review, okay? And as you send me questions to do, we'll talk about, again, what's on the test and what you need to be able to do.
The bent wire one would be a little bit mean.
Yeah, but you still have to do it. You still have to do it for homework, okay? So still do it. Okay?
Yeah, personally, I don't have too much issue with geometry, you know. Even though I was sleeping half the time in geometry class, that kind of stuff sticks with you a little bit, I think.
Yeah, I sat next...
I was sleeping because I was bored, not because I wasn't paying attention.
Yeah, sounds like you had my experience in high school. I sat next to an acorn in that class, and he got back in touch with me later, and he said, I'm all grown up, and he says, gee, I'm a tree. All right, so I like to start with a square root function, and I'll pick up the point 1, 0. And I want to find the min distance from the point to the curve, right? So find the minimum distance from the point 1, 0 to the curve y equals square root of x. If you notice, I already have my picture. I said you should have a picture. I already have my equation, right? I've got y equals square root of x. So somewhere I'm going to take that value of y and put it in to replace and get a function of x. Now, you should see a couple of things here. There is no, the distance can't be 0, and the distance can't be maximized, right? You can imagine that I could be, right, finding all these distances forever and ever. I'm never going to find a max distance, right? So we should get a nice expression. Sorry, we should get a good result for the second derivative, right? Clearly, we should get a positive value of the second derivative. We can't get a negative value out of it. There is no max distance. Well, we need a distance formula, but we should also try and visualize where this thing is going to hit on the curve. And if you don't know already, it always hits with at a perpendicular, right? It will always hit at a perpendicular. So
I was gonna say, I feel like it's gonna touch at an inflection point.
Yes,
sort of.
exactly. It's gonna perpendicular to the tangent at the point we find, right? So the segment representing the distance at xy should be perpendicular to the tangent line at x. Right? With our slope being f prime of x, right? So we're going to work on that today too. We're going to show that that's true. Yeah. So it's a pretty complicated problem, but if you're organized and just stay patient, you should be fine. And then just do every problem on all my old exams. There's one on every exam like this. All right, so getting a better picture of what's going on here, we know we have a point here. What should I call the point that's missing? I'm trying to find that point, right? So what should I call it?
Point P.
Sure, but I want coordinates.
Isn't it X?
EF of P.
X, Y, or better yet, X square root of X, right? So there's remember what I said, I have an equation? I'm going to have to substitute that somewhere. Now, all I need is a formula for the distance. Make sure it's on your formula sheet, right? The distance between A and B, right, is the square root of delta y squared plus delta x squared, right? So y2 minus y1 squared, quantity squared, plus x2 minus x1 quantity squared, right? So y2 minus y1 quantity squared plus x2 minus x1 quantity squared. Of course, coming from the Pythagorean theorem, right? Just to figure out a hypotenuse, I'm kind of figuring out, right, that hypotenuse. Okay, so I have the 2 points I want, and I'm going to usually pick the arbitrary point as my x2, y2. Okay, so here comes my formula. My function of x, d of x, square root of x minus 0 quantity squared plus x minus 1 quantity squared, right? So y2 minus y1 quantity squared plus x2 minus x1 quantity squared. And you see here I have a function of x, and that's what I need to do an optimization problem. I have to create a function of x. Most of the time it's a good idea to simplify this interior, so I will. So I get what? X plus x squared minus 2x plus 1. So I finally get my function that I want to minimize as x squared minus x plus 1. How are we doing? Who's that?
Working on it so far.
Who's that? I'm muted. What's it on? Oh, I just started loud talking. I thought. Oh, good.
Just one or the other, and I need both.
Oh, God. No.
So all of our y's are known because we're starting with the fixed point, and then
Yeah, we don't know the
we're
coordinate.
replacing the stuff
Yes.
with Pythagoras in
Mm-hmm.
with x and f of x, but the literal of it.
Mm-hmm. All right, we've got our function. Now we want to find our critical value, right? So d prime of x is what? I'll give you a second. Give me the derivative. It's okay. Anybody get it? Nice. So I actually like to write my first derivative with, since I can see the original function in it, I like to write it as 2x minus 1 all over 2d, right? So I can see my original function, the distance function there in that denominator. Well, why? It's just cleaner looking. And I know the distance can't be 0, so I don't need to think about a critical value downstairs, right? So all I have to do, and this will make my second derivative easier, all I have to do is find my critical value here, which I guess is 1/2, right? So I know d prime of x equals 0 gives me 2x minus 1 equals 0, gives me x is 1/2. Kind of makes sense on my picture already, right? So there is my point, my x value. What's the y value? Well, I know y is square root of x, right? So that's 1 over square root of 2, or rad 2 over 2, if I rationalize it. And I need to find the distance, right? So the distance at 1/2 is the square root of 1/2 squared minus 1/2 plus 1. Everybody okay? So I have the square root of 1/4 minus 1/2 plus 1. So I'm going to turn everything into fours, right? 1/4 minus 2/4 plus 4/4. So it looks like I get square root of 3 over 2 for my distance. That's my minimum distance.
That's a very sign-like answer.
Agreed. Coincidence. So I need still to find that this is a minimum distance, and then I want to show this perpendicularity, right? So we want to find d double prime. First of all, reminder of d prime.
So
yeah.
That square root of 3 over 2 is our x.
No, the x was the critical value, 1/2.
Okay.
The distance is square root of 3 over 2, yeah. So
Okay, so this is our perpendicular part, or
No,
this is our
we're gonna
hypotenuse part.
yes, yes.
Yeah.
So d prime of x was 2x minus 1 over 2d of x. I'm going to use a quotient rule here. So my upstairs function is 2x minus 1. The derivative is 2. The downstairs function is 2d of x. The derivative is 2 times d prime of x. And of course the downstairs squared is 4d squared of x. So I'm kind of like writing that d squared of x like cos squared of x, right? So our quotient loop is going to give us our second derivative here. I get 4 times d of x minus 2 times 2x minus 1 times d prime of x all over 4d squared of x. Well, but this is interesting because I know a couple of things here. I know when I plug in 1/2, this piece in green is going to go to 0, right? Either I plug in the 1/2 into 2x minus 1, which gives me 0, or I plug in the 1/2 into d prime, and that's the critical value, so that gives me 0. So there's no real reason to think about that piece when I plug in the 1/2, right? I really have 4 times d of 1/2 over 4 times d squared of 1/2. Well, the 4's cancel, and one of the distances cancel, right? So I get 1 over d of 1/2. But the distance is always positive. So this is positive. I guess I could write in the distance. What is it? Square root of 3 over 2? Is 2 over square root of 3, or 2 rad 3 over 3. But either way, it's positive. Positive people smile, right? Positive people smile, so I'm talking about a minimum here. Well, my conclusion is kind of obvious, right? I found the point. What was my point? 1/2. I forget already.
2 square root
Yeah, square
over 3.
right. No, my point was, where the hell is it? Yeah, rad 2 over 2, and the square and the distance is rad 3 over 2. So 1/2 rad 2 over 2 is the point on y equals square root of x that gives a min distance of square root of 3 over 2 to the point 1, 0. Here's my conclusion. I'd like to show that the segment, right, that I've created is perpendicular to the curve. So how do I show perpendicularity? Anybody remember?
Is it the reciprocal?
Yeah, the slopes are opposite reciprocals. Exactly. So I want to show that if I get a positive 3 over 4 for one of the slopes, I should get a negative 4 over 3 for the other. So I want to show my slopes are opposite reciprocals, right? So just looking at the picture one more time, I've got the square root of x, I've got my point 1, 0, I've got my point 1/2 square root of 2 over 2. And I've got this green segment, right, that should be perpendicular to this purple segment. So I want to show the purple tangent line. At x equal 1/2 has an opposite reciprocal slope the green segment connecting the points 1, 0 and 1/2 rad 2 over 2.
This problem has the same answer if the function is y equals sine of pi x over 2.
Yeah, but the distance.
They intersect. If you put it on Desmos.
Oh yeah.
Yeah, the sine over pi x over 2.
Oh yeah,
when you
yeah.
Have,
sure.
When you have a point at 0 or 1, 0.
Jesse, this problem is complicated enough. don't give us more to do. All right, so let's find the slope of the segment first, right? Well, that's easy, right? It's 0 minus rad 2 over 2. It doesn't matter. Over 1 minus 1/2. So negative rad 2 over 2 over negative 1/2. So I get a positive rad 2. Agreed?
Yes.
Or did I make a mistake? Oh, I made a mistake. It's a negative rad 2, right? And look at my line segment. It's obvious. Obviously, it's negative slope. Sorry. Nice slope of the tangent. I need some help here. Well, how do I get the slope of the tangent?
Don't we just put it into f prime x?
Exactly. So we're going to put that in the derivative. Derivative of square root of x is 1 over 2 square roots of x, right? I'll start it over. So y equals square root of x gives me y prime is 1 over 2 square roots of x. So the slope is going to be 1 over 2 square roots of 1/2. And that's 1 over 2 times square root of 2 over 2, which is 1 over square root of 2. What do you know? I got the reciprocal. I got an opposite, negative to positive, and square root of 2 compared to 1 over square root of 2. Reciprocals, opposite reciprocals. Since the slopes are opposite reciprocals, we know the tangent line in the segment, or the lines are perpendicular to each other. Beast of a problem. What will I do on your test? I'll change the function. I'll change the point. I'll change both. but the process is the same. I would imagine you would, on your formula sheet, put an entire problem like this, right?
Maybe he'll make it sine of pi x over 2. And we'll all
You're
cry.
saying y equals sine of pi x over 2?
Yeah, inside parentheses, yeah.
Yeah,
Yeah.
It's kind of hideous to think about this in that distance formula, though. It's really,
Maybe on a
Hideous.
closed interval.
it's hideous. I won't do that. Right, think about that y value inside of my distance formula. I'm going to have sine of pi x over 2 minus some point quantity squared. So I'm going to get a quadratic and sine inside of a radical. Not going to happen.
So I think up the extra credit questions and then don't answer them.
Yeah, and then don't answer them. Yeah.
Or file it under something to look at later and
Right.
forget to do so.
Let me save face a little bit on that problem from yesterday where I had a piece of wire. Is everybody okay for me to move on here? Thank you. So I had a piece of wire that was 10 meters long, right? And I cut it into two pieces, X and Y. And I know X plus Y was 10, right? Or better yet, Y equals 10 minus X. And I bent the X piece into a square, right? This was 4.6, number 25. It is your homework, so please finish it. So I have sides of X over 4, right? And an equilateral triangle, right, with sides of Y over 3. An area for the square is X over 4 quantity squared. The area for the equilateral triangle was 3/2 times Y over 3 squared. And I had put cubed in accidentally. Let me just double check that real quick. Sorry, square root of 3 over 2, Y over 3 squared. Yes. Wait a minute. Let me just go back to yesterday's. I'm having a meltdown again. There it is. Oh, square root of 3 over 4. Sorry. Oops. And like I said, if I gave you something this complicated, I would give you that formula. Double check it for me though, right? Just do a quick let me just double check one more time. Let me put in my X. So I know my base is Y over 3. I know.
Square root 3 over 4 a squared is area.
Yeah. Side squared, right?
Hold on, let me look at the representation with side. Yeah.
Okay, so I'm just double checking. Base is y over 3. Height is square root of 3. Sorry, yeah, square root of 3 times y over 6. And area, then it's going to be 1/2 the base times square root of 3 times y over 6. Yes, this is correct. So remember what we were doing, right? We knew that x plus y added up to 10, and then we're trying to maximize the areas of these two shapes, right? So clearly our function, right? By the way, y is 10 minus x, right? So f of x pretty quickly becomes x squared over 16 plus square root of 3 over 36 times 10 minus x squared. I just put that y value in there. And there's my function I want to maximize. Okay. So just trying to save face a little bit from Monday. We all make mistakes. Nice. I'm done. I don't want to do anything else today. I'm going to start chapter 5 on Friday, get some homework done. Remember, don't do 4.1 homework assignments. I'm going to try and teach that if I have to, if I want to, at the end of the, maybe in the review session or something. I don't know. All right. Have a great day.
Okay, that's
Bye, Professor.